So in this video we're going to solve a quadratic equation that has a leading coefficient of 1, and we're going to use the zero product property to do that. So the leading coefficient is the coefficient or number that is on the squared term. So here I have x squared, and the leading coefficient of this quadratic equation is 1, because 1 is the coefficient on the x squared. If I only see one x squared, I don't need to write the 1 in front of it to see that I have one of them. If there's more than one, I would need to put a number as a coefficient that wasn't a 1. So if I do 3x squared, that would mean, hey, I have 3 x squareds. So leading coefficient is 1 because there is only one x squared term. So I write x squared minus x minus 6 equals 0. And I want to use the zero product property. And to use the zero product property, which says, hey, if I have a times b equals 0, then either a is 0 or b is 0, I need to rewrite my quadratic on the left-hand side as a product that is equal to 0. And right now it's not written as a product. So the way that we can write a quadratic equation as a product, if the leading coefficient is 1, one technique to do this is kind of to look at the constant term, the minus 6, and think about the factors that can produce a negative 6 nicely. So for example, negative 1 times 6 is negative 6. 1 times negative 6 is negative 6. So these are two factorizations of negative 6. We could do a negative 2 times 3 to get a negative 6, and we could do a 2 times negative 3 to get a negative 6. So here's 4 factorizations of negative 6 that are nice. And when we're factoring kind of by guessing, we want factorizations that are nice. When the factorizations are not nice, then there will be other techniques that we can use to deal with the situation. So of these 4 sets of factorizations of negative 6, one of them, if I grab the factors, the 2 and the negative 3, and I add them together, they actually add up to the coefficient on the linear term. This is the x to the first or linear term. And the coefficient is negative 1. I see the minus sign in front of it. I see only one x, so it's really minus 1x. So as long as the two factors add up to the coefficient on the linear term, and the leading coefficient is a 1, I should be able to get a factorization of x squared minus x minus 6 equals 0 from these two factors. So I grab it and I say x and x, and it's going to be plus 2 and x minus 3, and those should equal 0. So this is a factorization of my quadratic. I have an a, parentheses touching means multiply. I have an a times a b equaling 0, which means I can use the zero product property. If I need to check my work on my factorization, I can always multiply this out. So I could come down here and say x plus 2 times x minus 3, and I could use the distributive property to check my work. X times x is x squared. X times minus 3 is minus 3x. 2 times x, and then 2 times minus 3 is minus 6. And then I get x squared, combine the like terms, minus 3x's plus 2x's is minus x. Minus a 6, and I get back my original, means I did my factorization correctly. Usually you don't list all of the factors. Usually what you do is you look at your constant term and you say, I need factors of negative 6 that when added together will give me a negative 1, the coefficient on the linear or first degree term. And then you usually try to say, hey, there's a 2 times 3 is 6. Ooh, look, if I put the negative on there, 2 plus negative 3 will equal negative 1, which is what I need. So you usually try to kind of mentally hone in on the factors that are going to do what you need them to do. Once you get it to the factored step, you apply the zero product property. Say, hey, I have two things multiplied equaling 0, so either this first thing, x plus 2, is equal to 0, or the b term, the second thing, either that is equal to 0, so x minus 3 equals 0. And now I have two linear equations in a single variable, so I'll solve them. Subtract 2 from both sides. Add 3 to both sides. So this, I get x equal -2 or 3, both as solutions. I could do these as a set. I could say x is an element of the set. The solution set that contains a -2 or a 3 would be another way to report the answer. So one more example. Type equation here. That's not a very interesting example, is it? So it's let's go x squared minus 11x and plus 30. So obviously I forgot to type my example in. So to do this one, I would rewrite my equation. And the constant term is a 30. So I need factors of 30 that add up to the coefficient on the linear term. The linear term is minus 11x to the first. So I need factors of 30 that are going to add up to a -11. And I can only do this because the leading coefficient is 1. So this technique is specific to having a leading coefficient of 1. There will be other techniques when we're in a situation where the leading coefficient isn't 1. So what I want to do, I don't want to have to list all of the factors of 30. So I'm going to hone in on one that I think will work. 5 times 6 is 30, but 5 plus 6 would be positive 11, and I need a negative 11. So I'm going to need to do -5 times -6, which will still give me positive 30. But -5 plus -6 is the -11 that I need on the as the coefficient on the linear term. So my factorization is going to have x and x, because x times x is x squared. And it's going to be -5 and -6. And again, we could check to make sure that we didn't make a mistake in our factorization by multiplying these out. So x times x is x squared. X times -6 is -6x. -5x. -5 times -6 is plus 30. And I get x squared minus 6x's minus 5 more of them is minus 11x's plus a 10. Sorry, plus a 30. My bad penmanship there made me misread it. And that is what I started with, so my product checks. So once I get it factored into a times b, I take my a, which is x minus 5, and I say, hey, either you need to be 0 or my b, which is my x minus 6, either my x minus 6 needs to be 0. And then I have two single variable linear equations, which we already know how to solve. We add 5 to both sides. We add 6 to both sides. So combining this, x is equal to 5 or 6. Or if we put it in set notation, we would say x is an element of the set that contains 5 and 6.